Okay, in the last video we talked a little bit about 2D fields and how we could use point attractors to change the geometry of those fields. Now we're going to talk a little bit about 3D arrays. Now you could say go back to the first two videos on arrays and build a 3D array in the same way that you built the 1D array or the 2D array using series or range. I'll go over a third potential way of using it. You can decide in your assignments how you want to build it. So I'm going to start off, instead of building up from a set of points, I'm going to start from a larger volume and divide it up. So let's make a box. And I'm going to make a center box. You see there? And so center box will take a plane. So you could also build these on some of the planes of your arrays earlier. And it'll say the size of the box in the X direction, in the Y direction, and in the Z direction. So I'm gonna build, let's make it twice as tall. Something like that. Okay, so I can start to take that box apart in a way that it divides it up into smaller sort of elements. So already building the geometry as sections of this box. So I'm gonna deconstruct the box. So that gives me the domains in the X direction, the domains in the Y direction, and the domains in the Z direction. Now, just like you divide a curve or divide a surface, you can divide the domain. So I can divide that domain, let's say, in 10 parts. So you can see that what was from -1 to 1 now is broken up into 10 subdomains that are smaller, that go from -1 to 1 in total. So I can do this for X, Y, and Z directions. I'll clean that up a little bit. And then if I want to build new boxes with these domains, I can do that. I can say a domain box. In this case, it comes in from -2 to 2. 0.05 to 0.5, and from 0 to 2.5, just the random value integers. Now if I plug these values into it, you can see I get similar things happening. I'll turn off this box so you can see similar things happening that we did with the 2D array, where these things were all sort of stacking up instead of building a 3D array of those objects. So we can use our cross-reference again. Cross-reference these two, zoom in. You can add a third one to cross-reference with the Z direction. Also need to make sure we have the X, Y, and Z plugged into those, so we have the right size division of that domain. So now we have this original box shape. Turn these off and you see that original box shape is now subdivided and made into 10 equal parts in the x direction, which I can adjust. You have 10 equal parts in the y direction, which I can adjust. And 10 equal parts in the z direction, which I can adjust. Okay, so then this would be like my 2D array mapped with the surfaces, except now we have a 3D array already with objects in that 3D space. So we can do things that start to use the attractor points and sort of adjust what these objects are doing. So we need some attractor points to sort of determine where we're going to move these objects. So I can populate 3D, and that'll just fill a 3D box similar to how we did the 2D surface populate 2D. I can use this initial box and it'll fill that with points. Now that's a lot of points. I'm going to try to turn that down to let's say 7 points. So this box is now filled with these 7 points, and I'm going to use these points to determine how I'm moving or rotating or coloring these boxes. So one way to do that would be to sort of get a distance to these points, find the closest point, and use that distance as some sort of attractor value. So how do I get the distance to these boxes? Well, I can get their volume. In doing so, they'll give me center points of each one of these boxes. I have these other points that I've mapped to the space. I just need to know which one is closest. So let's say the closest point. And so this, you feed in point to search from, and the cloud of points to search. Okay, so we want to find the closest point to each one of these center points. So the point to search from is going to be that point. And the cloud of points is actually going to be the random populated points. So that'll search through all these points and find which one's closest to all of these points. And in doing so, it'll give me the closest point. It'll give me the index of that point. It'll also give me the distance. Now the distance is what I'm most interested in. So then I can start to rotate, for instance. I'll rotate 3D. I'm going to take these boxes. I am going to say this distance, I'll associate this distance with the angle to rotate. You can already see that it's starting to do things when I turn these off. They're already starting to rotate around some point that you can see. I'm going to make this a rendered view so you can, oh, still have the other ones on. I still can't see them that well. I'm going to put a custom preview on there so you can hopefully see this a little better. Okay, so they're kind of rotating, not very controlled, but kind of controlled around where these points are. Let's give them a different way of rotating. So let's build a vector to rotate them around. We can say a vector from 2 points, and maybe a vector from the xy plane to the center points would be a good vector. So that will basically point from the center plane to each box. Okay, so that gives it some organization that you can see. These are starting to rotate with respect to each other. As that distance gets closer to some of these points, once you can see they're rotating more or less where they're closer to these points, more when they're further away from these points. And then let's also give them have them rotate around the center point, which I don't think it changes anything, but just to have some consistency with the other tutorials that we give. Okay, so we can also try to see if we can color code these to something that's more legible or understandable. So just all being pink. So what value should we use to determine that? Maybe the distance is just a good value to use in general. So like before, I want to remap these numbers. These distances are going to be all over the place, but I want them to be from 0 to 1. So I'm going to find their bounds. Their current domain and the new domain that I want to use. And then we'll try the gradient again. So you have a gradient. Let's make a different reset, like black and white maybe. We can plug these remap values into that. These into here. Oh, sorry, not those. Those into the material. And there you can see where it's closer to the points, it's white. It's further from the points, it gets black. So that associates some value for the rotation and the color as well. Now we can come in here and also maybe affect the rotation a little more. Try grabber again. Maybe I'll use this remapped distance. Give it a, let's try it. No. Let's see what a parabolic. Me too. So we can have some range. We can say, okay, it's going to go crazy, or it's closer to the point. Gives us a little bit of control over how it's rotating. And we want it to be more controlled where it's closer to the points and rotate a little differently. Anyway, you can play around with those sort of things. We can also go back and sort of change some of the original structure of it. So we can say, okay, these are going to get wider or shorter in those directions. maybe you could think of these as housing units or some other geometry in a larger building. You can make it a smoother transition. Towers. Anyway, so that's another way of making an array. You can use any of those sort of versions, whether you're sort of dividing up a 3D form. You can create grids. You can create a series and then put them together into 1, 2, 3D grid. You can use your range and domain and construct points. And all of those will work to make various types of arrays. And then when you use them for attractor points, you can start to use distances from points. You can use a distance to a line or some other geometry, and that can affect the attractor point rotation or translation or scaling. You can do that as well. You can say, okay, I'm going to scale each one of these geometries by their center point and factor the can't scale a factor of 0, so let's really small fraction. It doesn't go completely to 0. You can see what that starts to do as well, building in these smaller units and larger units with respect to that. So you can use all your transformations, come up here and sort of play around with scaling, shearing, moving, and see what you can do for your assignment.